Hey, what's up, everybody? We're back for another C++ lesson with my son, Alex. How's it going, Alex?
Hello, it's been a bit.
A little bit, not too long, but we wanted
Oh,
to give you a chance to let the information from the past tutorial sink in so we could come back and hit you with some more C++ goodness.
yes, I have absolutely no idea what we're going to discuss today, so this is all new to me.
Yeah, great. Well, this is good. This is good because I'm sure you'll have questions and hopefully I'll have the answers.
Yeah.
Great. So I'm going to share my screen with you. Okay. So today we're going to go further into the world of inheritance with virtual functions. Have you ever heard of virtual functions before?
I've heard of their existence, but I have no idea how they function.
Okay. Cool. So this will be a brand new one for you. Okay, so just an overview of what we're going to do. First thing we're going to do, since it's been a little while, we're going to do a quick review of what class inheritance actually is, just the very basics of it. And then we're going to do a high level overview of virtual functions, coding concepts, and a practical walkthrough. So I'm going to test you right now, Alex. What is class inheritance?
Class inheritance, I believe it's when uh, it's when you use a class within a class.
Okay. So can you explain a little bit further what that means? A class within a class.
So, suppose you use a class one earlier in the program, and then you have class two. So, from my understanding, I believe you can use the features from class one and class two to make further, I guess, edits in a
Okay.
sense.
Could you give me an example of something that may use class inheritance, like just a practical example, real world?
Yeah, so maybe you have a game and you start off with a car. So you start with the car model, like a Ford or a Nissan, whatever. And then in the second class, kind of like a branch, you can change the wheels of the car or you can change some other feature of the car.
Mm, yeah, very close, very close. I think that's the idea is right. So I would probably say something more like class, the base class would be something like a car, and then your inherited class would be a specific type of car, maybe
Oh, okay.
for
Yeah, okay.
a Ferrari, and it might have its own speed, might have its own wheels. But that's pretty good. Yeah, that's pretty good memory. So yeah. So just a review. So a lot of your kind of hello world of inheritance for many people is an animal. So you have an animal class. So you have like dogs, fish, horses, and they all may do the same sort of things like move, eat, sleep, and so on. And then maybe we have some sort of specific behavior that we want to add to a class, to an inherited class, so something like snore loudly, which is something that a French bulldog might do, but that a fish would not do.
Hmm.
But both of them are animals, right?
Hmm.
So the key thing to understand here is that French bulldog is an animal. So it is a class, it's a subclass of animal and can call any of the public member functions that you can call an animal. So French bulldog could also call move and eat.
Hmm.
Okay. With me so far?
Yeah, that makes sense.
Great. So now we're just going to extend on that by talking about virtual methods. Okay, so there are a couple concepts that are closely tied together. So you hear virtual methods, you hear another one that's closely related called a pure virtual function or pure virtual method, which
Hmm.
is very closely related, but we aren't going to do that today. We'll do that a little bit further. And then the third thing that's related to that is what we call an abstract class. And we will talk about that once again in the next lesson. So we'll talk about pure virtual functions and abstract classes in the next one. But today we're just going to talk about normal virtual functions. So what is a virtual function? So most people think like virtual reality, and that's not quite it. It's really a way for us to override a function that's declared in the base class with our own implementation of the function in a derived class. Okay, so I'm going to show you what that means in the next slide with the same class. So we have animal, and so this is our base class. And the only thing that I've done differently here is I've taken void move and I've added this virtual keyword in front of it. Okay, and you can see that in the method body, I just have this. It shouldn't be stood cost. It should be C out. But the autocomplete in Keynote changed it. So that should be C out. And we see that we have this thing, I'm moving, right? It's just going to print that out to the console. Right. Now we have this class that's fish, called fish. It inherits animal. And now we have a move function and we have another keyword called override. And we see that we're doing, once again, this should be C out, not C, not cost. And we have I'm swimming rather than I'm moving. So do you see what's happening there? So we see that, so just to summarize, we see that any animal that you may have is probably going to move in some way, right? But animals move in different ways. So a horse may gallop, a dog may run, and a fish may swim. So what we're doing is we're allowing the developer to be able to implement create their own implementation of this method, even though in the base class there is already a very basic implementation of I'm moving.
Right. Okay. So when you override it, you can make it whatever functionality you want, right? It doesn't have to be a stood C out or anything like that.
That's right. Yeah. So this is just something that's very generic, right? You know, it could be anything. Like if you were doing a shape, right? So let's say that you had a base class that was shape, and you had and then you had a derived class that was, let's say, circle, right? And you had another derived class called triangle, and then you wanted to calculate the area of a triangle versus calculating the area of a circle. So those would be different, right? You know,
different formulas.
Even though that would probably be better as a pure virtual function rather than just a virtual function, but we'll talk about that next. We'll talk about that in the next lesson. But these two things are kind of very similar to each other. The essence of it is that you have a base class functionality, and now you're just changing it, or you're extending it with your own implementation. Okay. So now we're going to do a little walkthrough, and I'm going to show you why these are important. And hopefully I won't get too complicated for you. But let's start off. So we'll just use this same example, right? So class animal, and then we need to make sure that we declare this public, because our derived class needs to make sure that it has access to this method. Right? So we got this void move, and then I'm just going to stood C out. I'm moving. And once again, we just need to put this virtual keyword in front of it like that. Okay. Now we have another class. So once again, let's say this is class fish, and we will inherit it by using that colon and saying public animal. could ever spell it right. And once again, we need to declare it as public so we can use it in our main class. And now we're going to say void move. And do you remember the key word after this?
Override.
Override, exactly. Okay, and then we will just change this to I'm swimming. All right. And then if we wanted to, just to knock this point home, we could have another class, and let's call this class dog. And then once again, we have one of these, and we will just say I'm running. All right. So that's the reason why we have virtual functions, so we can extend the functionality of something that's basic that's happening in our base class. So if we had a class of enemy, so there's different types of enemies, might be a monster, might be a soldier, and then you had a virtual void attack method, the way that a monster is going to attack may be different from the way that a soldier is going to attack. Does all of this make sense so far?
Yeah. One question. So let's say, this is an extreme example, but let's say you had like an organism, I can't think of one right now, that doesn't move at all. Like a plant. We'll just say a plant. And for the sake of argument, it'll just go under animal. And we don't want the move function to do anything because it couldn't actually move, but we still wanted it under the animal class. Could you theoretically just put nothing in between the brackets and basically cancel out, quote unquote, the functionality of it?
Theoretically, yes, you could do that. But then it would really make it a bad case for inheritance, because if you had plant and then you classified it as a type of animal, you want to make sure that anything that's in your base class can be done in your derived classes. Okay. You wouldn't want it. You wouldn't want to start splitting hairs where you're saying, oh, well, this class that I want to inherit can do some of the things that animal can do, but it can't do all the things.
Right.
That would probably be a good case to make a separate class. So that's the way that I would handle it. But in theory, that's correct. You could make a void move and then override the base class and theoretically not put anything in there.
Yeah. Okay.
Great. So let's start this off simple, right? So we could create a fish object, right? And we say fish.move. And we see that we get I'm swimming as expected, right? So now I'm going to show you a few things. Well, first thing I'm going to show you is that I think if I take out this override keyword, it'll give us a warning, but it won't necessarily. Interesting. It doesn't even seem to give a warning. Why is that? That's interesting. Normally, maybe I don't have the right compiler settings, but normally it would give a warning that you're using a virtual method, but you're not using the override keyword. Override is normally something that'll give you a warning, but not an error. But override is just more for the reader. So if somebody else is going through, or if you're going through at a later point and looking at your code, and you see the override keyword, now that's just a way of letting you know that hey, this move function actually is overriding something that is first declared in your base class. Okay, so override. Go ahead.
So the functionality isn't in the override keyword.
That's correct. That's
Okay.
correct. Yeah. So another little trick that I will show you is you could actually remove virtual here. And I don't think, yeah, see now this will give us an error. And you will see that if I do this, this will still work, right? And we still see that I'm swimming, right?
Interesting.
So yeah, so that's fine. So it's like, well, why would we use a virtual method, right? Why would you do that? So, and I'm going to show you here. So let's say that we have this void. Let's call it. I'll just call it do something, and let's say that it takes a pointer to an animal, and this is where things start getting a little bit more complicated. We're taking it to the next level now. Okay, so anytime you have a pointer like this, you want to make sure before you try to do something to your pointer, you want to make sure that it's valid. So you can just say if animal like that, and then we will say animal move, right? So we're using the arrow operator because this is a pointer. Okay, so another way that another way that's saying the same thing is you could say if animal is not equal to null pointer. Okay, so that's just making sure that you actually have an animal there and that you're not trying to access something that doesn't exist. Okay, does that make sense what I've just said there?
Yes.
Okay, cool. So now what we'll do is we will make a stood unique pointer of type fish. I'll just call this fish, right? So I'm making a unique pointer of fish because I don't want to declare raw pointers most of the time. Remember, it's best practice to use smart pointers like unique pointer. Okay, so I know this might be hazy for you, but this is a little bit of a review of just some C++ basics. Okay, so always try to use smart pointers over raw pointers, especially when you're first starting. Okay, so what I've done is I've declared a unique pointer of type fish, right? And now to actually create that fish, so to speak, I have to use this function called make unique, stood make unique, and it's of type fish. And to create it, I don't need to do any arguments. Okay, so now I've just made a fish, right? And now what I could do is I can call that do something function. And in here, I can put my fish in, okay? So since it's a smart pointer and not a raw pointer, I need to use this function called fish.get. That just gets me the raw pointer to the fish.
Okay.
Now, when I do that, it's going to call animal. So I'm putting fish in here. And so I'm saying basically fish move, right? So what do you think it's going to console out? I'm moving, I'm swimming, or I'm running?
I think it would output I'm swimming.
Okay, so let's have a look.
Okay.
Okay, that surprises you, right?
I was kind of torn because it's a pointer to animal, so it makes sense that it would output I'm moving.
Exactly, right? So that's the reason why we need this virtual in here. So virtual is what allows us to be able to tell it allows our program to be able to tell that this is actually this pointer is a pointer to a fish, not just, and a fish is a type of animal, so that works, right?
Okay.
So so that's why Oh, what's happened here? So this is virtual void move. I've done void move override. Oh, sorry. It's right here. So this is, oh, I'm getting all mixed up. So virtual needs to be up here in animal, not in fish. There we go. So now we will get, I'm swimming. Okay.
Okay.
Because um, it's basically deriving that it's deducing that that this is a fish and the fish is a derived class of animal.
Okay, so let's say I took your advice with plant and I made a new base class called plant. And
Okay.
then I want to do the same thing with plant as you're trying to do with fish, but since it's not an inherited class of animal, would it just not work or would it bug the
Yeah.
whole program?
Well, great question. Let's have a look, right? So we will do class plant, but it doesn't derive from animal, right?
Hmm.
And
Yeah.
then let's say that I just have this void move function that doesn't do anything. And now, so I will just put this out like this. And then, sorry, I will comment this one out as well. And let's see what happens. So I'm going to actually copy the three of these and just put plant in. So this is now plant. And then once again, plant. And here we got plant.get. Okay, so let's see what happens. Yeah, it just says build failed. No matching function for call to do something because it expects an animal pointer.
Okay.
Yeah.
That makes sense. Yeah.
Okay. Cool. So yeah. So that's um, yeah. That's really it. Yeah. Any questions on that?
Hmm. So removing the pointer from void do something would also cause the program not to work or run incorrectly.
Okay.
I'm sorry, from the
So let's say that we do this. If animal, and then let's put an else in here. Stood, see out. Your animal doesn't exist. Like that, right? So let's say that I just comment this out. Now we get your animal doesn't exist because we haven't actually allocated memory for our fish,
okay.
right?
That makes sense. Yeah. So just there's nothing to point to.
That's right. Exactly. Yeah. So what we've done is so a pointer is exactly that. It's just a pointer. It's just pointing to a memory space. It's not the memory space itself, right?
Mm-hmm.
When we call make unique actually creates the box and puts a fish in it, and then
Yeah. Okay.
it
That makes
points
sense.
to the box.
So without that, it's just pointing to nothing. It doesn't have anything.
Exactly. Yeah, it's not pointing to anything.
So does the pointer get destroyed um after you make it if it's not used?
You're that's so it's not. So let's think about this. It's not pointing anywhere. No memory has been allocated. So it wouldn't do anything.
I'm thinking
Whereas,
it would sit there because it's an int main. It's not within like the scope of another function. I feel like it would just sit there and then maybe 20 lines later you could call it and it would still function like normal. Or you can allocate
oh
fish.
yeah, yeah, yeah. So as long as you're within the scope of the unique pointer, you can allocate it at any point in time. Yeah, you can actually call make unique, and that's really why what the function of having a pointer is good for, because that's exactly what we mean by dynamic memory. It means that at the start at the start of your application, you may not need to allocate all that memory for a fish, right? You might not need it until you've painted your aquarium or whatever you're doing in your program.
Yeah. Yeah.
And then once the user has you know, chosen what they want to do, let's say they want to make an aquarium, now you want to make your fish. So that's when you make your fish, you allocate the memory, and then you do all the things you need to do with the fish. And then when you're done, then when main gets finished, then those fish get deallocated, right? So that memory gets freed up. Okay. Sometimes what you can do, and this starts getting into the nuances of pointers and things like that. So um, sometimes if you're using a raw pointer and you call delete and then you try to do something to it afterwards, you're going to get undefined behavior, because what happens is that even though you've called delete is actually kind of a misnomer, because it doesn't actually delete the memory. It just marks it as able to be replaced or freed up.
Mm.
Yeah.
Kind of like hard drive memory. It's when you delete a
Well,
program.
it is, except it's RAM. Yeah,
Right.
it's RAM. But yeah, that's exactly what it is. It's memory. Yeah. Yeah. So rather than doing this, you could also do animal star fish like this. Oh, sorry. I want this to be a fish. So this is a fish pointer. And then I could say something like auto f equals new. I'm sorry. I want to say fish equals new fish like this. And then I don't want to use fish.get anymore. And then after this, you got to say delete fish. Hopefully I did all that right. I don't. Yeah. So that's how that works. But even if you, like I would imagine that if you do this, I'm not sure if it'll throw an error or not, but what will probably happen is it'll probably say I'm swimming, because it hasn't. Yeah, see that? So just because
that's strange.
Yeah, just because you've said delete, it doesn't actually delete the memory. It just marks it as able to be written over.
So could it get corrupted? It's kind
Yeah,
of
yeah. Well, that's the danger of using raw pointers. That's why you don't really want to do this, because what happens is, let's say that do you you do all this stuff, and then you call delete, and then you write a whole bunch of code, right? Or you're doing a whole bunch of stuff in a huge application, and then you try to do something to the fish after you've deleted it way, way, way down the line. Now you're running into undefined behavior, because that memory might have been written over with something else. And now you're trying to access into a memory place where that fish doesn't exist anymore.
Interesting. It kind of became a whole discussion on pointers, huh?
Yeah, kind of, but it's important. It's important to know, and I think pointers is something that um, is a big item of discussion. It takes a little while to get your head around it, uh, to to actually get your head around what's actually happening. But yeah, that's essentially it. But yeah, try to use a unique pointer. Try not to use raw pointers uh, unless absolutely needed. But yeah, that's the essence of what virtual functions do. So big thing to remember about virtual functions, they have a base, they have an implementation in the base class, okay, and that you can change what that behavior is in the derived class.
Hmm. That's pretty useful. Thanks for
Yeah,
teaching me that. Yeah.
cool. Yeah. So yeah, what do you think about that one? That'll give you something to be busy with for a little while.
Yeah, class. I haven't been messing with classes enough actually. So this is inheritance seems like a huge step forward from just, basic classes.
Hmm. Yeah,
So,
yeah, it is. It is. And there are a lot of nuances to it, but you'll get them. And there are a lot of different rules for when you inherit a class, what you can access and what you can't access and things like that. But to be honest, I just look those things up when I'm not sure. And I'm sure that experts do too until they've been, uh, you know, working for 20 years or something. So,
I'm sure even those guys still run into issues.
mhm. Yeah, exactly. Cool. So yeah, so that's it for this one. Yeah, if you found that helpful, please be sure to smash that like button and and subscribe. And for the next tutorial, what we'll do is we will cover abstract classes and pure virtual functions. Uh, cool. So we will see you next time.
Peace.